Well, in your DSC syllabus, there are two types of chemical cells, and they are metal coupled cells and cells within the electrode. And there are two ways to separate the solution from each other, and there are several ways to balance the charge from the half cells. And there are progress reports in stoppage. And in this video, I will illustrate some of the examples to show you how chemical cells can work. For the first one, what's the meaning of metal coupled cell? It actually by use of the difference in reactivity of metals, the difference in tendency for the metals to lose electron to establish an electron flow. But just randomly draw an example with a voltmeter between two of the metals. So one of them it may be zinc and the other one it can be Cu. And then we just dip it into an electrolyte. And the difference between electrolyte and conductor is that the electrolyte will actually decompose when conducting electricity. And maybe we use CuSO4 copper 2 sulfate solution this time. And what can you think of? Which of zinc or which of the copper it has a higher tendency to lose electron? Well, according to your knowledge from maybe reactivity series or electrochemical series, of course, zinc being more reactive and it will lose its electron more readily. So in this cell, zinc it will lose its electron and then it will go into the external circuit by passing through this voltmeter and then to reach Cu. And what happened here is that for Cu, because zinc is continuously losing electron and then it will go to the copper side, and then copper metal, it will becomes negatively charged because the electrons are accumulated here. And it will become negative. The next thing you think of is that what species inside the solution it will migrate, it will move through this negative electron. Of course, because of the electrostatic attraction, the cation, there is a positive ion, they will move towards this copper electrode. And in the solution, there are two types of cation. The first one comes from the copper 2 sulfate itself, is copper 2 plus ion. And the other one is H plus. H plus comes from the self-ionization for water molecule, and it will split into H plus and hydroxide ion. They are also cation, and they will be attracted by this negatively charged electrode. And the problem is that which of these two is a strong oxidizing agent, which of them will prefer to gain electron more preferentially, of course, is Cu2+. It's because for copper metal, it cannot react with acid. It means that copper 2 ion is a strong oxidizing agent than H+, so that there will be no reaction between copper metal and this hydrogen ion. And after you know this result, you can immediately write down two equations. For zinc, it will preferentially lose its electron, and then zinc, it will become zinc 2 plus and 2 electron. And the zinc 2 plus, it will go into the solution, and then for electron, because they cannot swim, so that they will not get into the solution, but instead they will go through to the external circuit, passing through this voltmeter, and then get to the electrode of copper. And then at this copper side, the copper 2 ion, they will reabsorb the electron. And what happens if Cu2 plus absorb that electron? They will form copper metal. So they are in this simple chemical cell by using a metal coupling reaction. For the zinc side, the electrode will become smaller and smaller. It's because zinc react to become zinc 2 plus, and the zinc 2 plus will go into the solution. And then on the copper side, the copper 2 plus ion in the solution, it will absorb electron, it will undergo reduction, and then form back some copper metal. And where will it be formed? Of course, on the copper electrode, so that it will become bigger and bigger. So you can see that there is some brown solid deposit on the copper electrode. And then the final thing about this reaction is that because copper 2 ion, it reacts to form copper metal. It means the concentration of copper 2 plus in the solution will become lower and lower. And zinc 2 plus ion, it has low color. So that the overall result is that this copper 2 sulfate solution, it will decreases in the color intensity of blue. It will become more and more pale blue. And finally, it may become colorless. And that's it for this kind of metal coupling cells. And of course, you can use another way. It's because for this simple chemical cell, the zinc metal, it can directly undergo displacement reaction with the copper 2 sulfate solution below. So the scientists think of another way for the cell to react. They said again a photometer, and then again a zinc electrode, and a copper electrode. However, this time we can separate the two solutions to avoid displacement reaction to occur directly. By, say for example, for this side, we immerse the zinc ion into zinc sulfate solution, and then for the copper 2 side, for the copper electrode side, we immerse it in CuSO4 solution. And then the zinc, it cannot directly undergo displacement reaction with the solution below, and it can generate an even higher voltage. However, if the setup is only look like this, it cannot conduct electricity because for this part, they are not connected. It's not a complete circuit. So then we have to add some more things called a sorbage. A sorbage can be made by immerse the filter paper into some aqueous solution of an ionic compound. This is an electrolyte, and the common choice are sodium nitrate or potassium nitrate. As long as the chemical itself, it cannot react with the electrode, it cannot react the solution, it's a good choice of electrolyte. And sodium nitrate or potassium nitrate, they are quite chemically inert, so that they are a good choice for this reaction. And in this case, the case is just similar. For zinc being more reactive, it will lose its electron and then it will go to the copper metal. And then in the solution of copper sulfate, two of the cation will move towards this negatively charged copper electrode. The first one, copper 2 ion, and the second one is H plus from the self-ionization of water. And what you have to think of is which of them will gain electron more preferentially, and of course, copper 2 plus. So on this side, there will be some brown solid deposit. And then because it will absorb electron, and on this side it will lose as electron. So if we without this sorbage, this side, because it continuously losing electron, so on the zinc half cell, it will become more and more positive, and on the contrary, on the side of copper electrode, it will become more and more negative. And here comes the second use of this sodium nitrate solution. The first one is, of course, to complete the circuit by using some mobile ion to migrate through this two side. And the second one is that if the zinc part it become more and more positive, and then the nitrate ion can migrate through this half cell and to balance the charge. And on the contrary, for the copper 2 side, because it continuously accepts some electron, and then the electron will be gained by this copper 2 ion to become copper metal, so that this cell will become more and more negative. So as a result, for this sodium ion, it will continuously migrate towards the cell on the right hand side in order to balance charge. And if this sorbage it doesn't exist, of course there will be no complete circuit, and electricity cannot be passed through. And the second thing is that the charge will accumulate. For the Cu side, it will become more and more negative, and for the zinc side, it will become more and more positive. Yes, this side will become more positive, this side will become more and more negative, and eventually the whole cell will stop because of the accumulation of charges. So it's the second use of this sorbage. It provides ions to balance the charge in order to prevent the reaction to stop. Okay, and another modification is by use of the porous pot, and the setup is look like somehow this one. The zinc Okay, again it is one of the electrode, and then they will be blocked by a porous pot. And outside there is another container consists of our copper electrode, and then there will be some CuSO4 aqueous outside, and then inside there will be some zinc sulfate solution. Oh, and this apparatus is called a porous pot. And the meaning of porous means that there are so many holes on it. It actually allows some of the iron to pass through, so that it allows current to flow or electricity to float. And the second use of this porous pot is avoid the mixing of the two solutions. And again, in this chemical cell, the zinc it will be the most reactive species, and it will lose its electron to copper metal, and it will become more and more negative, and it will attract copper 2 ion, and hydrogen ion 2 was this Cu electron, and of course Cu2 plus will gain electron preferentially, and then there will be an increase in mass of the copper electrode, or there will be some brown solid form on this copper electrode. And then on the other hand, for zinc, it will lose its electron to form zinc 2 plus ion. Then if without this porous pot, the charge will accumulate on this zinc and this copper metal side. And the use of porous pot is allow the ion to pass through and to balance the charge. And that's it for the metal couple cells. And the other types of cell is by using some inner electrode in a chemical cell, just like graphite or some platinum electrode. Maybe I use graphite in this case. Graphite. And randomly pick a solution. Or it cannot be worked. Well, for a chemical cell with inner electrode, we have to separate them into two half cells with an air voltmeter in between, and of course our stoppage is littered. And if the electrodes are chemically inner, it means that in the solution there must be some strong oxidizing agent or reducing agent, and use one of the strongest oxidizing agent in your syllabus, that is MnO4 minus. And then on the other side, I use Fe2 plus AQ solution as an example to show you how does it work. So in this case, with the electrode, they are chemically inner. We use graphite as the electrode. Graphite. Hope that you understand my handwriting. Graphite, one form of the carbon. And then what you have to think next is that which of these MnO4 minus or Fe2 plus is stronger oxidizing agent. Of course, MnO4 minus, it will reduce back to Mn2 plus in the process, so that in the process it will gain electron, because its oxidation state for Mn, it will change from +7, and then it will decrease to +2, so that it will gain electron. Because of the decreases in oxidation number, it will have a reduction reaction. So immediately we can draw the electron flow. And then what you have to think of is that how can this Fe2 plus lose its electron? Of course, it can lose as one electron to become Fe3 plus and our electron. And the Fe2 plus become Fe3 plus. Fe3 plus will go into the solution, and then for electron, it cannot swim. It will go through to the external circuit and then go to the MnO4 minus, and then forces MnO4 minus part to undergo reduction to become Mn2 plus. Is it clear? And because again of the electron flow, this side for Fe2 plus, it continuously loses electron, it will become more and more positive. So that if you use KNO3 as the stoppage, the K plus part, because it's positive, it will migrate through the KMnO4 part. And then the nitrate ion, because it's negative, and then for this side, because it continuously loses electron, it will become more and more positive. The nitrate ion will in fact move towards this half cell in order to balance the charge. This is how this cell with a chemical, the inner electrode works. And on this side, because MnO4 minus, it will become Mn2 plus. And in the process, MnO4 it actually undergo reduction, it actually gaining electron. And this side, it will become more and more negative. So that the K plus side will migrate towards this KMnO4 in order to balance the charge. And this is the second types of chemical cell you will learn.